Okay, in this video, we will discuss how to properly write ionic formula. Okay, so remember an ionic compound contains a positive metal cation and a negative non-metal anion, and or a polyatomic ion. And it's a combination of those two, the plus and the minus charge, that makes the ionic bond, right, and makes an ionic compound. So we're learning how to now write the formulas. Okay, so an ionic formula will contain the positive and negatively charged ions. We always write it so that it is neutral, right, that the charge is balanced, that the total positive charge is equal to the total negative charge. The symbol of the metal, or the cation, right, is written first, followed by the symbol of the non-metal. Okay, so for example, sodium, remember, loses an electron, becomes the cation. Chloride is the anion. So we would write the metal or cation first, sodium, right, then the chloride. So NaCl, and the charge is -1, +1, +1, -1, and the charge is balanced. Okay, and the compound as written, right, is neutral. Okay, let's look at some more examples. Okay, so remember, the total positive and the total negative must equal 0. Write the cation first, then the anion. Use subscripts to show how many sets, right, are needed. And use parentheses if you have two or more polyatomic ions. Okay, so we just went over this example of sodium chloride, +1, -1. Now we have calcium nitrate. So calcium is a 2+ because it's group 2. Nitrate, we know, is NO3-. So in order to make the charge balance, we need 2 nitrate ions. So we'll have a total of 2+ to balance out the 2-. Okay. Since we have 2 nitrates, we're going to need parentheses when we write calcium nitrate. Okay. Sodium sulfate. Sulfate is SO4 2-. So we know that we're going to need 2 sodium ions to balance that charge. So we have Na2SO4. And there's no net charge. So +2 balances with the -2. Okay, so you can go through these other examples. Here's barium chloride. Notice that we don't need parentheses if it's just a single element, but with barium phosphate, you are going to need parentheses around the phosphate to show that you need 2 of these. Right, so it's very clear. Right, let's do some practice. Okay, so we're combining sodium with the ions above, the bromide, sulfate, and the nitride. Okay, so we see that sodium is +1, bromide is -1, so they balance, so you'd write NaBr. Now we have sodium +1 and sulfate -2. We're going to need 2 sodiums to balance out the sulfate. So notice when you write the ionic formula, you are not seeing any charges. It is written as to be electrically neutral. Okay, so now nitride is a 3-. This is a 1+. So we will need 3 sodiums to balance out 1 nitride. All right, so why don't you pause the video, try aluminum on your own, and then start the video again. Okay, so now we have aluminum. That's the cation, so that one's written first. It's a 3+. The bromide is a -1, so we'll need 3 of those. Now this one has aluminum 3 plus and sulfate 2 minus. What I could do here, this one often confuses students. Let me just write it down here. So if we know aluminum only comes in 3 plus and sulfate comes in 2 minus, you need a common denominator, right, which is 6, right, between 2 and 3. Okay. So we need 6 pluses and we need 6 minuses. So how do we get 6 plus? Well, we need 2 aluminum ions. How do we get 6 minus? Well, sulfates only come in 2 minus, so you're going to need 3 of those to get a total of 6 minus. So then you add up your total. You have 2 aluminum, and you will need parentheses for the sulfate, and you have 3 of those. Okay, so you're writing the compound so it is electrically neutral. Okay. Now we have aluminum and nitride, 3 plus, 3 minus, so it's just 1 to 1. Okay. Okay, so write the formulas for the compounds containing the following ions: the calcium ion and the fluoride ion. So this gives you a little bit of practice of using your periodic table and determining the charges of the ions. So calcium is group 2, so we know that's always 2 plus. Fluoride is a halogen, so it's always a 1 minus. Now we're going to combine those together so that the charge is electrically neutral and get calcium fluoride. Aluminum, that one's always 3 plus. Oxide is always 2 minus. Okay, so the common denominator is 6. So Al2O3, right, is how we would write aluminum oxide. Sodium, group 1, plus 1. Carbonate, it's on the 7, so there's 3 oxygens. It is a -2 on our number line. So sodium carbonate. We need 2 sodiums for every 1 carbonate. Sodium again, bicarbonate, has an H. Neutral takes away 1 charge. So 1 plus and 1 minus. It's sodium bicarbonate.